All right, here we've got our last video for section 9.6, and we're going to look at another word problem here. And in this situation, we're going to look at a simulation of someone jumping rope, and we're going to model the height of the jump rope with a sinusoid function, so either sine or cosine. So let's look at the situation first. So two people swim jump ropes, as shown in the diagram. The highest point of the middle of each rope is 75 inches above the ground, so that's the height, the maximum value, and the lowest point is 3 inches, so that's our minimum value. The rope makes 2 revolutions per second. Okay, now remember, that's going to be our frequency, 2 revolutions per second. Now, what you want to remember is frequency is equal to 1 over the period. And remember, the period is 2 pi over b, so the inverse of that is b over 2 pi. So we're going to get that the frequency is b over 2 pi. So what we get is 2 equals b over 2 pi. And we're going to use this to solve for our b value. Write a model for the height in inches of rope as a function of time in seconds, given that the rope is at its lowest point when time equals 0. Excuse me. So what this is going to look like is we're going to have our axis right here, and we're going to have height is going to be our vertical axis, and time is going to be our horizontal. So we want to know what's happening to the height of the jump rope as they swing it around. Now, you can see that if we look at, imagine here is a height of 75, and here's a height of 3, which is what the jump rope is going between. We're going to see that this jump rope is going to be at, when time equals 0, the jump rope is going to be at some small height, and then the height's going to increase as the rope goes up, and then it's going to hit its maximum, and then decrease, and then hit its minimum, and then increase as it hit its maximum, and so forth. So, and as they keep swinging the rope and time goes on, you're going to get this function that's a wave function. Okay, so this isn't the exact graph right here, but you can see how modeling the height over time gives us a wave function, which we're going to use a sine or cosine to measure. Okay, so let's first figure out what we have to do. So we know that the rope is at its lowest point when time equals 0. Okay, so what that means is here at our y-axis, when time equals 0, this is when time equals 0, the rope is going to be at its minimum, at 3. So what we have to do is we need to figure out if we're going to use a sine or cosine to measure this. Now, I'm just going to draw our diagrams of a sine and cosine. Remember, a sine function starts here and goes up and comes down and comes back up. So a sine function starts at the midline. Now the cosine function, if you remember, starts at its maximum and then ends at its maximum. So we want, if you look at our function, we want this to actually start at the low point. We want it to start when time equals 0, it's at its minimum. One thing that we haven't talked about yet is reflections with sines and cosines. Now, if I go ahead and draw a standard cosine function here, you can see what it looks like. We started our max and ended our max. This model that we want to get right here is actually a reflection of a cosine function. You see, this is just our wave flipped upside down. Instead of starting at the maximum point and ending one cycle at the maximum point, we're going to start at the minimum point, go up to the max, and go back down to the minimum. So we're actually going to model this using a reflected cosine function. And to get a reflection, all that means is that we have a negative a value. We just put a negative in front of this. So you're going to see that as I go through the steps here. Keep in mind that we're going to introduce a reflection. Both sines and cosines can be reflected. A sine function, for example, if it was reflected, would still start at the midpoint, but then go down to the minimum and then up to the maximum. So reflections just take your graph and flip it upside down. Okay, so let's go ahead and go through the steps now. So first thing that we do is we know that our minimum is 3 and our maximum is 75. And as I already showed you, we can model this with a sinusoidal function. So we know the max is 75, the minimum is 3. So what we need to figure out is where our midline is going to be. So in this case, our midline is going to be at 39, because if we take 75 plus 3 gives us 78 and divide it by 2. Again, if we look at our graph right here, okay, we see that if we have our minimum here of 3 and our maximum of 75, the midline is just going to be halfway in between that. So we just get that by adding these together and dividing by 2. So that's going to be our midline. That's going to be our k value. Okay, so let's go ahead, keep that in mind. The next step, we've already discussed that we want to model this with a cosine function. And because the height is at its minimum when we start, it's going to be reflected. Okay? Because we're starting at time equals 0, we're not going to have a horizontal shift. We're starting our period right at the y-axis, so there's not going to be an h value. H is going to equal 0. Okay? So what we want to do is now we need to figure out the amplitude. Now remember, the amplitude is just the distance from the, it's the maximum value minus the minimum value divided by 2. So the amplitude of this is going to be 75 minus 3 divided by 2. So it's going to be the height from the midline to our maximum value. So the height from 36 to 75, or the height from 39 to 75 is 36. So again, the amplitude is just the halfway. It's just the distance from the midline to the maximum value. Okay, so now we've got our vertical shift. We've got our a value right here. Now we just need to figure out our period next. So remember, we talked about how the frequency is just equal to b over 2 pi. So we get 2 equals b over 2 pi. And if we take this to isolate b, we multiply both sides by 2 pi, we get a b value of 4 pi. Okay, so that's going to be our b value right here. Again, we're using the formula frequency equals 1 over the period. And the period is just 2 pi over b, so that gives us frequency equals b over 2 pi. So that's how we get that formula right there. Okay, so now if we look at everything, we've got a k value of 39, we've got an a value of 36, we've got a b value of 4 pi, we're using a cosine function that's a reflection. So let's go ahead and put all that together and write our function. So the actual function that we're going to get, we put the negative for our reflection, 36 is our a value, we just got, that's our amplitude, b is 4 pi, there's no h value, so no shift, and then we get plus 39 is our vertical shift. So that's going to be our value right here. That's going to be our formula. Okay. Now what I want to show you on Desmos, here is the difference between if we have here is our parent function for cosine. When we do a flip, this is what our graph looks like right here. So this is going to be what we're actually using to model. We have this flipped over cosine. And you can actually see here is a sine function and a negative cosine, and you can see the difference. Here's what happens when we flip a sine function. Here's our parent function, and here's the inverse. So when we have a reflection, it just takes our graph and flips it over the x-axis. Okay, so that's how you do this problem. Again, with these word problems, it's all about going through, picking out the pieces of information, finding the right function to model this. So the key here is understanding that because our minimum point is when t equals 0, because our period starts at a minimum, we have to look which one of these functions has a minimum point to start out with. And out of all these different options, you see we've got a sine, a cosine, a flipped sine, and a flipped cosine. The only one that starts at its minimum value is our inverse cosine. So that's how we determine which model to use for this. For any word problems that you see, it's all about identifying, does your period start at the midpoint, maximum, or minimum, and then using the proper function with the proper transformation appropriately. All right, so what I want you guys to do now is, you've got a very similar problem. Two people swing jump ropes. The highest point in the middle of each rope is 80 inches above the ground, and the lowest point is 2 inches. The rope makes 2 revolutions per second, so that's the frequency. And remember that frequency is just equal to 1 over the period. Okay, so you're going to use that to solve for your b value. I want to write a model for the height of a rope as a function of time, given that the rope is at its lowest point when t equals 0. Okay, so this is exactly like what we just did, but some of the values are different. So make sure if you have any questions, you can go back, rewatch the video, make sure you take good notes throughout it. Again, you've literally got the exact same problem, but just some of the values have changed right here in terms of the minimum and maximum. So for your answer, go ahead and type in your function. Again, if you don't have pi on your keyboard, just type in pi instead of the symbol. That's fine. So go ahead and type that in now into the text box that comes up. All right, just like we always do, I've got a Google form for you guys to go into. When you answer these forms, I want to know what you learned from this section. And I want to know what questions you have from this section. So what specifically about some of the formulas, the concepts that we learned. Please, if you have generic questions like how is this used in real life, come talk to me during tutorial and we can talk about that. Or if you have questions about anything else that's not related to this section, please come talk to me outside of this. In this form, I want your feedback from this specific section. So go ahead, I've got the link for you in the text box that's going to pop up. Go ahead and follow that, and when you're done, write in completed. Only write completed when you've gone ahead and completed the form. Otherwise, you don't get credit just for typing in completed and not actually doing the work.